All right, now for the good stuff, we get to our first interesting one. So what you notice here, again, we're being given a little story about what the velocity of something is as time goes by. And so what's going on here before we, just to kind of orient ourselves, is at the beginning, when t equals 0, whenever we start our stopwatch, this thing has a velocity of -2. So it's moving backwards. And it's moving backwards, but then as time goes by, it continues moving backwards. And the reason I know it's moving backwards because the velocity is negative, but it's moving backwards at a slower and slower rate, right? Then here at this point, the velocity crosses 0. So the velocity goes from being negative to being positive. So this little point here is some kind of a turnaround point. So I'm going to write that there, turnaround. We switched directions, right? The velocity was negative. It was moving backwards, moving in the negative direction. Then it turns around and then it starts to move forward or moves in the positive direction, okay? So what we're supposed to do here is get the acceleration graph and a position graph. Well, going this way is easy. As we've seen before, you just need to read the slope of the velocity graph. Well, you can tell the slope is 1, okay? So it's the slope of this graph is always 1, so the acceleration is always going to be 1. So this is a constant acceleration, 1 meter per second squared, okay? Right, so as 1 second goes by, the velocity increases by 1 meter per second. That's the very essence of having an acceleration of 1 meter per second squared, right? So again, the bottom graph is the slope of the one above it, right? So, but now what we need to do is get the position graph, right? So what we run into here is it's more complicated than the one that we did earlier, because here the velocity was, say, 3 meters per second for the full second. Well, so of course, if you go 3 meters per second for 1 second, you've moved 3 meters. I can't just multiply the speed here of 2 meters per second times 1 second or something, because the velocity doesn't stay 2 meters per second during that time. It continuously changes, okay? So what we can do, though, is use this little area trick that we saw before. And so what we can do is say, well, during this first second, the area between the curve and the axis is 1.5, 1.5. And I'm actually going to call that negative 1.5 because it's moving backwards, right? The velocity is negative. So what that means is in the first second, it needs to move backwards or in the negative direction by 1.5. So after the first second, it's going to be there. Okay, 1.5 units down from wherever it started. In the next second, you can see that this area, again, between the axis and the curve, is minus 0.5. I'm going to put a little arrow to it, I guess, minus 0.5. And so that tells you how far to move during the next interval. And so what we want to do is go down another 0.5 from the starting point of the previous interval. Well, so what you can see from this is we're starting to build up a curve. Okay, so we start here. It's going to go down like this. Now, just to see if this makes sense, early on in the interval, we were moving very fast. So the position slope was very steep. Then we approach a velocity of 0. So we should be approaching a flat slope. Okay. Then, now this is a turnaround point. So then during the next second, this little chunk here, this thing has an area of 0.5. So we need to go in the positive direction half of a unit. So we end up here. During the interval that comes after that, now we're speeding up. So we're going to move pretty, farther during the next interval. During this next interval, you can see that we move 1.5. You can kind of just count boxes. 1.5 from where you were before. So go up 1.5. Now, if you pause here, kind of a neat thing to see is we're back to where we started. And a way to see that is whatever negative area we generated here, that's been compensated by the positive area we've generated here. So the net area is 0 for the first 4 seconds. And so that's why we're back where we started. And then we just have one more interval to keep track of, which is this last one. So you can count boxes 1, 2.5. So this is going to be 2.5. So let's go up 1, 2.5 from where we started, and we will end up there. So you get this curvy position graph for cases where your velocity is constantly changing, right? Now, what I like about all this stuff is after you generate the position graph, you can kind of pretend to go backwards and see if it makes sense. So if we had started with this graph, you know that you read the slope of this graph to get the one below. Well, so what this one kind of tells you is, well, we start off with a big negative slope. The slope approaches 0. The slope gets to 0. And then the slope climbs and climbs and climbs up and goes upward. So you have this neat back and forth check between these graphs. Likewise, I mean, this is maybe overkill, but you could even imagine going upward on this graph, right? During the first interval here, you would say the area is, you could say the area is 1, and that's why the velocity changed by 1 during that first interval. Then you say, oh, the area under this curve is 1 again, so then it changed by another 1. So that's another way to check the relationships between these graphs.